Hello, and thanks for having me. For the next 15 minutes or so, we are going to take a step back and try to not get lost in the latest science discovery and all of its wonderful details. Instead, we are going to take a look at how we can ensure that our science is usable by others, other scientists, engineers, operations specialists, policymakers, industry partners, or well, really anyone. Today we're going to compare tracking progress frameworks and hopefully convince you to use the application usability levels, or AULs. I'd like to first thank my collaborators and the research and user communities, as we have been having these ongoing conversations for a number of years now. Each time we learn more about what is useful, what is needed, and where we can make improvements. And we hope that you will join in on these ongoing conversations. So why use a framework to track the progress of your research or of something that you hope to transition into an operational setting? Perhaps more generally, we can ask the question, why track the progress of your project whose outcome you hope others will use? A tracking framework can really help us bridge and navigate the valley of death. Often we think of the valley of death as the transition between research and operations. But it really can be any sort of valley where you are taking your research and trying to ensure that it will be usable by somebody else at the end of your project. For example, this could be ensuring your model outputs work as inputs into another researcher's model. Or it could be ensuring your analysis code can become a part of the newest Python space physics package. Or perhaps it is ensuring that your CubeSat data follows fair data practices and is ultimately archived with user documentation into your field's favorite public data repository. A tracking framework can ensure that there is clear communication between the developers and researchers and the users of the product about the use and current development stage of the product. We want to hit on those three things again, as they're incredibly important. We want to make sure that there is clear communication about the use and current development stage of your research, your product, your tool, or your science that will be used by somebody else. So which frameworks are out there, and what were they designed to track? The TRLs are probably the most well-known and were developed at NASA to ensure that a piece of hardware, and later generalized to include flight software, would be ready for use in the space environment. They have 9 levels going from TRL-1 to TRL-9. They range from basic technology research to technology development and demonstration to finally demonstration of use in the space environment. The TRLs were developed as a method to estimate the maturity of technology for spaceflight. This helps enable risk management, as you can look at a piece of hardware and know fairly well if it is going to work in space. The TRLs can then help at the mission and proposal formulation and planning stages, as they can tell you if the hardware or software will allow you to get the required observations. If the technology is not at a level ready for spaceflight, then development funds may be required to ensure success at launch. One of the quite interesting things about the TRLs is that there is no requirement to identify a user or the user's requirements. Implicitly, this is sort of stated, but it is not explicitly included. All that is stated to reach a TRL-9 is that the technology must be able to work in space. I suppose there is a bit of an assumption that once you build the device, there will be users who will use it. NOAA uses the readiness levels, which, like the TRLs, have 9 levels going from basic research to deployment and regular use. Similarly, there is no requirement to identify a user, but instead, there is an identification of research and development output to an operation, application, commercial product or service, or other use which addresses or serves a NOAA mission need. The NOAA order, which defines the 9 readiness levels, was developed with the motivation to establish the process for identifying, transitioning, and coordinating the R&D output to operations, applications, commercialization, and other uses. It is recognized that not all applications which start out at an RL of 1 will reach the RL of 9, as requirements are tailored to address the NOAA mission needs. The application readiness levels were developed at NASA by Lawrence Friedel and others within the Applied Science program. These were developed to generalize the TRLs so that they could be used for technology beyond spaceflight and with industry partners. They also have 9 levels and 3 clearly developed phases: the discovery and feasibility phase, the development, testing, and validation phase, and the partner demonstration and transition phase. The ARLs are used as a communication tool to convey the progress of a product towards sustained use, as an analysis tool to assess the progress towards completion, as a reporting tool to funding agencies, and we'll talk a bit more about that in the next slide, and finally, as a diagnostics tool to identify roadblocks in development. Each ARL has clear milestones which must be met for an application to advance to the next level. During a grant cycle, teams are asked to state what the current ARL of the application is and how many levels they expect to progress. The teams then update the funding agency each fiscal year. It is not expected that a project will advance from ARL 1 to 9 in a single grant cycle, but using this framework, the research team and funding agency can still show continued progress of the project. If all similar projects are getting stuck at the same level, one can then try to determine if there is a common roadblock. Perhaps a specific type of data is needed to complete validation. If so, then the funding agency can make the case for the need of a new mission to obtain this data and thus address and remove the identified roadblock. The application usability levels, or AULs, were developed by the space weather community and published last year. They also have 9 levels and 3 phases: the discovery and viability phase, the development, testing, and validation phase, and the implementation and integration into operational status phase. You may see many similarities to the ARLs, and in fact, the application usability levels were developed in consultation with Lawrence Friedel. It was he who suggested the name change along with addressing lessons learned from the other frameworks, and that was because of the importance of the motivation behind usability instead of readiness. It is all fine and good to make sure something is ready for use, but it is much better to ensure that there is a want for the product and that it can and will be used immediately upon completion. So a bunch of us came together from the space weather community and identified barriers for effective applied space weather research. This includes knowing how to find and best communicate with the user community, as well as knowing what research will produce useful tools wanted by the user community. For example, an end user may not need a tool stating the likelihood of EMIC wave growth, but instead need a tool saying what the radiation environment in low Earth orbit is. A radiation belt modeler then may be the researcher for that end user, but that same radiation belt modeler may be the user of the EMIC wave analysis tool. Understanding who needs what products and their requirements can help us better direct our research and create the needed tools for different users. By providing useful products which meet the user requirements, we can help build trust and strong collaborations between these communities. Then, when the researcher or developer reaches out to say how other projects may be useful, a conversation can begin and the start of development of new products for new applications. So we really see the AULs as providing 4 functions: as a communication tool to show the progress towards sustained use of the project with the identified user, as a reporting tool for the developers to convey progress towards user requirements and metrics and for users to report things like the operational environment, as an analysis tool to assess the ability of the project to meet the agreed upon requirements, and as a diagnostic tool to help identify roadblocks in development, which can also then be used to identify new applications and new users. Each level has clear milestones which must be met for a project to advance to the next level. Both the user and researcher must agree that the level has been attained. It is not sufficient for the researcher to decide this on their own, as we want to ensure the use and usability of the product for the user. The AULs allow for the progress to be shown without necessarily completing science closure in much the same way as the other frameworks do. We do not expect that in a single grant cycle a project will go from AUL 1 to 9. However, the AULs provide a framework to show continued progress towards completion. If the user requirements change, then a new branch is generated. This allows for the continued development with the original requirements and clear reporting on the progression of the new product down the AUL path. We like to think of this as an aspen grove, so you have your basic science research at the roots, which can allow for multiple different users and use cases to come up as clear new trees. But along each use case, you may have different users with their own requirements or operational environments, which become new branches of the same or similar product. So how do we map between the different frameworks? When comparing different frameworks, we can look at how others have done this in the past. As an example, here is a comparison for the international scales of rock climbing. In this example, each scale has the same motivation, which is to inform the user about the difficulty and technical ability needed to successfully complete the route. We can attempt to do a similar mapping. However, there are areas without one-to-one correlation. For example, no user is identified in the TRLs or RLs, and the ARLs and AULs do not require operation in the space environment or that a business case be made. The reason the one-to-one mapping doesn't work is that there are clear differences in the motivation for the frameworks in what they were designed to track. Thus, the question to ask is which framework is right for your project? What are you trying to track? Let's take a closer look at the motivation behind each of these frameworks. For the technology readiness levels, it's really quite simple. They are asking the question, will this tool, be it software or hardware, work in the space environment? For the NOAA readiness levels, the question being addressed is, what is the maturity of a product and where is it in the transition process towards addressing a NOAA mission need? The application readiness levels answer the question, will this product work in the user-specified environment and aid in a decision-making context? The application usability levels are asking a much more generalized question. Will the output of this project, be it software, hardware, data, or something completely different, be able to provide a specific use and aid the identified user? This is where the difference in the motivation for the AULs really stands out. The AULs transform the monologue of the researcher or developer from the other frameworks about their project's progress into a dialogue with the user, ensuring the product's usability and the want for the product upon completion. The AULs provide a framework for a continuing dialogue based in best practices. This consistent conversation ensures that from the start to the end of the project, all parties are aware of the expected use, requirements, metrics, and user guides and validation techniques, as well as the reporting and documentation for the project and its progress. Each framework can ensure clear communication between developers and researchers and users about the use and current development stage of a product. The AULs also explicitly ensure clear communication about who the user is and consistent communication between the researcher or developer and user. So it really depends on what the goal of your product is as to which of these frameworks would be best to use. If flying in space is your goal, then perhaps use the TRLs as they are an industry and ISO standard. If you are transitioning a product for use at NOAA, perhaps RLs are the correct way forward. If ensuring a product's readiness for use in industry, then it may be the ARLs you want to use. If ensuring usability by someone else, then we suggest the AULs. The AULs have the added benefit of having the user and researcher agree upon metrics to achieve throughout the AUL phases. So when using the AULs, the user and developer may decide to use the TRLs or RLs as the metrics which need to be met. So I hope that this has helped identify different types of tracking frameworks, why you might want to use one, and how they might be used in different situations. Thank you for listening. You can join the conversation and our ISWAT working group at the link on the screen. And you can find more information and resources, including these slides, at our GitHub page. If you need a bit of fun, check out our mapping of AULs and TRLs on Twitter. And we hope to chat with you soon.